This is Honors Geometry, section 6.2 on coordinate problems. So as for these first three examples, determine whether the convex quadrilateral is a parallelogram. So I have the coordinates for points A, B, C, and D. And I'm going to start by giving myself a good enough graph. So point A, point B, point C, and point D. So A, B, C, D. And it says the name of this is supposed to be A, B, C, D, so I feel good enough about my drawing that if I go around the perimeter, that's a good name. And the easiest way to prove something is a parallelogram or determine whether it's a parallelogram is to use the definition. So I'm going to go after slopes. First of all, the slope of segment AB, so 2 minus 4 divided by 7 minus 3, and that simplifies down to -1/2 if I want to simplify it. And AB should have the same slope as DC, so I'll do that one right underneath it. Slope of DC, I'm going to do 5 minus 7, that's -2. 13 minus 9, that's 4. That also simplifies down to -1/2. So if I compare those, we have parallel. So AB and DC are both parallel to each other. That by itself isn't enough, so we're going to have to go after the other sides. I'm going to look at AD. So the slope of segment AD needs to be calculated next. 7 minus 4 is 3. 9 minus 3 is 6. If I simplify that, then it is 1/2. AD should be the same thing as BC. So for the slope of BC, we have 5 minus 2, which is 3. 13 minus 7, which is 6. That also simplifies down to 1/2. Comparing those two lengths, they're equal to each other, so that means that these are also parallel. And because both pairs of opposite sides are parallel to each other, that means that yes, this shape is a parallelogram. Number 2, same process. So maybe you want to pause the video and try this one on your own. You can check it when you're ready. So point E, point F, point G, and point H. E, F, G, H. Here is the quadrilateral we're looking at. E, F, G, H makes sense with the name. So I'm going to go after the slope of EF first. So EF, 8 minus 8 is 0. 5 minus 2 is 3. That simplifies down to 0. Slope of HG, this is the one that's on the other side, so hopefully they're parallel. -1 minus -1 is 0. 5 minus 2 is 3. If you simplify those, you get 0. So these two lines both have a slope of 0, which means they're parallel. Anytime you have a slope of 0, that means you have a horizontal line. These lines are directly going side to side. For the other sides, let's look at EH. Slope of EH. -1 minus 8 is -9. 2 minus 2 is 0. That is an undefined slope because we can't divide by 0. And then we're going to compare that with the slope of FG. FG right here. So that's going to be -1 minus 8, which is -9. 5 minus 5, which is 0. That is also an undefined slope. So those are parallel to each other. If you have an undefined slope, that means you have a vertical. So we have two horizontal lines parallel to each other, two vertical lines that are parallel to each other. So once again, yes, this is a parallelogram. These first two examples are nice because we get to work with numbers. Numbers make the problem more concrete and easier to understand. Whereas in question number 3, we're getting into variables. The graph for this one could be trickier because I don't know exactly where those are at. So I'm using this name to really help me rely on what this is going to look like. MNPQ is the name. And now I can put my coordinates right next to them if I think that's going to be helpful. So A, comma 2B. N is A plus 2B, comma A plus 2B. Point P is 2A plus 2B, comma A plus B. and Q is 2A, comma, B. Now for the calculations, I'm going to start with the slope of segment MN. I'm going to show more work for this. So from M to N, I'm taking A plus 2B minus 2B divided by A plus 2B minus A. Subtract the numerator, subtract the denominator. There is the slope of MN. Going from MN, the Y value increased by A, and the X value increased by 2B. We went up A over 2B. Now for the slope of QP. So for QP, we have A plus B minus B divided by the X values, 2A plus 2B, this one, minus 2A. And if I simplify that, that's A over 2B. These are the same, so we have one set of sides parallel. MN is parallel to QP. Going a little bit further, let's check out NP. The slope of segment NP equals, so A plus B minus A plus 2B divided by 2A plus 2B minus A plus 2B. Make sure you're subtracting the entire quantities. So I see A minus A gone, B minus 2B, that's a negative B. Denominator, 2A minus A is A, 2B minus 2B gone. So there is the slope of NP. It's a negative B over A. Last thing to find is the slope of segment MQ. So B minus 2B, subtract the Y values in the numerator, divided by 2A minus A, subtract the X values in the denominator. We have negative B over A. These are equal, which means they're parallel. Both pairs of opposite sides are parallel. So once again, we do have a parallelogram. All about the slope. Slope will be able to verify whether or not something is a parallelogram all by itself. Number 4 is a slightly different kind of problem. It says RSTU is already a parallelogram. We just need to find the intersection of the diagonals. So because I have this name, RSTU, I'm not going to pay as much information as to where they're actually located. I'm just going to make sure it looks like an RSTU parallelogram. Put all of my points on here. And then see what I can do. It says find the intersection of the diagonals. So here is one of the diagonals, and here is the other diagonal. Now the longer way to do this problem is to find the equation of line RT, find the equation of line SU, use elimination or substitution to figure out where they intersect with each other, and got it. The other thing we can do, because I know it already is a parallelogram, and I know the diagonals of a parallelogram bisect each other, that means the midpoint of SU and the midpoint of RT is going to be the same because that's where they're bisecting each other. So if I were to calculate the midpoint of segment RT, x plus x divided by 2, y plus y divided by 2, that's the midpoint of this segment. If I did the midpoint of SU, I'd get the same result. This is the intersection of their diagonals because that is the midpoint for both of them.